Welcome back, ladies and gentlemen. We have with you Mr. Thomas Braun, President and CEO of Verisante. Mr. Braun, good day.
Good day, Michelle.
Are you very excited right now?
I am. Always excited
I would,
to be here.
I would be excited with what you came out with. How long have you been working on that? Because we spoke about your company. We told most of the important thing about that. And there are things I would like to know. How long have you been working on this prototype, can we say? Is not built in large numbers so far?
Right. I founded the company in 2006. We did an IPO in 2009, December 2009.
Okay.
And basically, the current model that we have, we licensed from the British Columbia Cancer Agency. We announced that in 2010. And so we started working on it very hard with our own engineering team in September 2010. So we're 12 months now building the mass production version. There was already a prototype, clinical prototype, that was used for 6 years at the Skincare Center, Vancouver General Hospital, tested on 1,000 lesions of live patients.
That was my question. How many, because they said small number of tests, but 1,000 is a big number of tests.
That's a big one.
With a result of 100% success.
No. The published results from 2008 were on a smaller group of 274 lesions, of which 34 were melanoma, and the device detected all 34. Oh. That was on a smaller group. Yeah. Then there was another publication of preliminary results on about 300, and they published 97% sensitivity. And now they've done 1,000 lesions, and that publication's about to come out.
Okay.
Has not been published yet, so I can't say.
Okay, but it's not a bad result.
No, it's actually very, very good, and miles better than just relying on the subjectivity of a medical doctor's eyeballs. Right now, they're just eyeballing it, and they have a magnifying glass called a dermatoscope.
Yeah.
Some of them use digital cameras. Photo booth, all sorts of things like that.
And even there, I remember myself being at my doctor and telling him, okay, what's that colored stuff I got there? You know, I'm afraid of cancer. Is it? He looked at it and he says, I don't think so. And he cut it off and sent it to a lab. So it knew it. So, and this device you had would have told us?
It would tell you in 1 second.
Yeah.
What the risk level is. So the doctor then knows, do I biopsy it or don't I?
Okay.
And this is very important because 80% of skin cancers are above the shoulder, so it's on your face. And so people like you who make their living based on their good looks because they're on TV every day, they don't want to get...
Chris, not me.
Yeah, they don't want to get unnecessarily biopsied on their face, the vast majority of which come back negative. Most people are fine.
Yeah.
But doctors are not walking x-ray machines. The way our device works is we're measuring the chemical composition. We're looking at biomarkers for skin cancer.
Okay, that's what it does.
That
was my other question.
Yeah.
Because it looks like a laser. We do have pictures to see here.
Yes.
So, it seems like you're looking at with like a laser.
Yes, there's a handheld probe that's connected to the larger device that houses, there is a laser in there, and it's shining an invisible infrared light on the lesion that bounces back, and it's collecting information at the molecular level. So based on those molecular vibrations, we're getting a spectral fingerprint. We can see things that you can't see with the naked eye, even with a magnifying glass. Mm-hmm. So this is just like a spectrometer that you would use in a laboratory, like a CSI, to determine what some kind of substance is. And it's been altered with a fiber optic and a handheld probe so that you can take it to the patient and take measurements on their skin. And that was developed over 10 years by the British Columbia Cancer Agency and the University of British Columbia, and we have the worldwide exclusive rights to it now.
I mean, I find it so interesting, and this is among what all of those application we can do with this sort of thing. Now you're talking about skin cancer, but it could also be applied to other area of the body, but if it can recognize a cancerous tissue, I mean, you could certainly do it in other type of cancer.
That's right, and we are. Skin cancer is the first one. It's outside the body, so we think it's the easiest one to do a clinical study on. Yeah. And skin cancer is the most common cancer, so we also think it's the biggest market. And this device is not just for melanoma. It is also for basal cell carcinoma and squamous cell carcinoma. And that's very important because melanoma, while it's the most deadly skin cancer, is only 4% of cancers, skin cancers.
Okay.
The other 96% are basal cell and squamous cell skin cancer. Those are rarely deadly, but they cause local damage. You can end up losing your ear or your nose. So it's very important to note that this product is doing all of those other cancers. That gives us a huge competitive edge. As far as the internal cancers go, it's the same electronics, but we attach a fiber optic probe that goes down the biopsy channel of an endoscope. And the first 50 patients have already been done for lung cancer, Vancouver General Hospital. We put out a press release in July. Go to our website, look at our past press releases. We link it to the journal that published the article on the results. 96% sensitivity, 91% specificity. What that means is that they would have called it right they would have caught 96% of these lung cancers, and they would have called it right 91% of the time. So you only have 9% false positives. And that was a huge, huge improvement over the existing technology.
I mean, there's such a big market for that. So you have the patent for that. You're the only one that possesses this technology.
Yes. So we've got the exclusive rights for skin cancer, lung cancer, the whole gastrointestinal tract. So that includes everything: the esophagus, stomach, large intestine, small intestine, colorectal cancer, and we also have the rights for cervical cancer.
I mean, there's so much. So with that big market, you told us that you were going to start with the skin cancer because it's the most popular and everything. But also, it's a large market. So you're a Canadian company. You are partnered with the Vancouver, British Columbia University.
Cancer
agency. And but the world is right there, and this patent is a worldwide patent, isn't it?
There are about 6 patents on the skin cancer device, and they're mostly in Canada and the United States.
Okay.
But there's a method patent on the whole method of using this Raman spectroscopy and 21 biomarkers to detect skin cancer, and that's currently at the PCT stage. That's a patent cooperation treaty. So that gives us the opportunity now to patent that, to file that method patent all over the world. And we'll be doing that because as a public company, we have the funding to do that.
Talking about funding, what are your, how much money do you have in front of you now to be able to exploit this
We're doing
project?
really well financially. We've raised over $7 million this year so far. We've got $5.5 million cash in the bank. Our burn rate's about $250,000 a month. So we're doing really well financially. And because of the volume of the stock, we can raise money in the future. But we don't want to really raise money right now because we think that we're just before Health Canada approval. Once we get that, we'll be able to raise money at a higher rate.
Why to dilute the company at 70 cents also?
Exactly.
You know, if you have plenty of money in front of you.
That's right.
Do you have any idea of how long? I said in the show earlier that I don't think this should take as long as a drug, because is this have any side effect?
It has no side effects. At the BC Cancer Agency, they actually measured the radiation, and it's less radiation than a cell phone. So it comes within limits set by ANSI, which is an American organization, but it's recognized internationally. We sent that information to Health Canada last year, and they said, okay, well, it's safe. We think it's a Class 2 medical device. And, here's the form that you fill out. There's a $350 fee. How long it takes them, I'm not sure exactly, because there is some back and forth. And I hate to second guess a regulator, and they probably hate me to second guess them too. So I'm not going to try and make a prediction other than to say we think we'll get it done by the end of the year.
Yeah, but if not, I think someone in the population should put pressure on them and stop being such a big thing. I mean, when it's no dangerous for the population, and when it can help the population, I think in some case they should make faster, because it's something we all always been waiting for, I guess.
Right.
And there's such a big market in front of you there. So which market do you think you're going to go after the first? States, or because after you got the Canada approval, you may get the Food and Drug approval quite fast also?
No, not quite fast. The FDA is totally separate. My initial contact with them, they said, look, you're from Canada, get approved by Health Canada, then come and talk to us. And I think that then they'll see us in a more positive light, because Health Canada is respected worldwide.
Yeah.
And they do take a close look at it, and they take a look at your evidence, and they want to make sure it's good. After Canada, the next place where we can get approval, because their system is very similar to us, is Europe. And that's a CE mark, and we expect to have a CE mark before the end of the year. Europe has 21,000 dermatologists. Big markets, Germany, United Kingdom, France, each with populations between 60 and 80 million. In Germany, they pay for skin cancer screening, 150 euros. So we think that those are huge markets for us. We're very excited about Europe. Australia recognizes the CE mark, but they require registration, which takes a couple of months. So we also think that we might even be into Australia approval before the year end.
Most of the time right now, if you go see your normal doctor for something that appears that you think it may be a cancer, very often they send you to a dermatologist.
Yes.
With this device, could the family doctor take more, I'd say, decisions on their own using the machine? If the machine tells us this is no cancer there, or...
Yes. And that's one of the reasons why the inventors of this device invented it, was because in Canada we only have 500 dermatologists for the whole country. That's one for every 60,000 people. There's just not enough dermatologists to examine everybody. So this is a device that can be used by a dermatologist's trusted assistant. They have a physician's assistant. Sometimes they hire a general practitioner to assist them for screening people. Absolutely.
Sure, why not? I mean, like you said, by your eyes, you may never recognize an early cancer, while this device, once proven really well working, why would we need in the first stage the dermatologist?
Exactly.
Every clinic should have that.
You could use this to check people out. If the device says, look, this is a high-risk lesion, you've got to go see a medical doctor to have it biopsied, or refer that person to a dermatologist.
You should put it in airport also. When you go through, they tell you, hey, by the way, you got a cancer here. Mr. Thomas Braun, thank you very much for being here. It was a very interesting device, and you have a very interesting company.
Thank you. It's great to be here, too. Thanks, Michelle.
Thank you.
Okay.